Okay, so in our last video, this is going to be the chance where we begin to try to figure out, is all of this work we're doing worth it in terms of energy savings? Okay, so I have already loaded up a colonial house. And again, you can do this with any of the houses. And again, they're just in the examples. And if you go to simple buildings, you can do a gazillion different analyses on different types of houses. Okay. You can even do it in famous buildings, White House, Empire State Building. And as you get these bigger ones, you probably want to make sure that you have a decent graphics card inside of a computer. Otherwise, it tends to get a little sluggish and can be slow. So that's why I'm just sticking with this one for right now. And what we want to know first is, let's just go with the default. So everything is going to stay exactly as the model has it with all the R values. All that I'm going to want to do is I am going to run an analysis on my building. And if in case you ever go to your analysis and you go to buildings, and we're going to do an annual energy analysis for the building, is if your building, if it's grayed out, is you might just need to select your building. But I've run into that as a little glitch from time to time. And generally it just works fine, but just in case. So let's do an annual energy analysis for the building. Okay, so this is going to be in Boston. We're doing it on December 1st, and we're roughly starting at 9 a.m. Okay, so we're going to compare basically every day to that. So let's run. All right, it's going to take a while. You can see down in the bottom left down here is where it's running through. Okay. And we're going to see up here our total energy usage. And notice our green, we don't have any solar panels, so we don't have any green. Red is kind of heating costs. Okay. And the blue is air conditioning costs. So not surprisingly, right, as we hit June and July, we start to go up. And then these purple dots are our net energy use. All right, so you can see heating is actually fairly high for us here in Boston in the morning. And this tells us our total energy costs here, 15,862 kilowatt hours for the entire year, okay, for this house. Okay, okay. So we want to keep that number in mind. And so for our final activity of kind of week one is we want to see whether it's worthwhile or not, and how long it takes for us to pay back our solar energy costs if we put solar panels onto the roof. So we'll want to write that number down. You can copy the data and it'll copy it right into a spreadsheet, but it's not nice, easy use spreadsheet. So I would just jot it down. Okay? And what I would do instead of um, copying this, I would just take a screenshot of this picture, because we're going to need that data later. Okay. And this also gives us our net energy costs. Okay. So we kind of have a rough sense of now what it is. All right. Now, let's go over. I'm going to close this. You want to keep the results? Not right now, because I took a screenshot. And so now if I look at my total costs, my building is $211,000. Okay. So now let's add some solar panels onto this house. Okay, boom. And I'm gonna solar panel the house up. And one of the things that we want to do is we want to have just the right number of solar panels, such that we are minimizing our initial startup cost, but also making sure that we're saving the maximum amount of energy. And so in some cases, you can over solar panel your house if you're living in the right areas. All right. So now I've got my same house. Nothing else has changed. I've just added solar panels to it. Okay. So now if I go back to my costs, my solar panels cost, what color are they? They're the yellow ones. So if I move over the little yellow piece of the pie chart, $24,000 to put on my solar panels. Okay, so they did a pretty decent job where that also includes the panels, the installation costs, things like that. So now the question is it worth it, and how long does it take for me to get my energy back? So if we remember that I had about 16,000, let's just round it up, kilowatt hours per year. I'm going to do exactly the same analysis. So I'm going to go to my buildings, I'm going to run my energy analysis, and we're going to run. All right. So we're going to sit here and watch it. This is the exciting part of the exercise. All right. So notice our net isn't nearly as much. Okay. So we're only at 4,500. Now this is where our solar panels begin to really start to come into play, right, in the summertime. Because we begin to get a lot more hours of sunlight. And you can notice over here, it changes on how many hours of sunlight you get. Right, so June and July are maximum sunlight hours at 9 a.m. Okay. So there we go. So I'm now at 6443 kilowatt hours. Okay. So now the interesting challenge to figure out is how many years does it take for me to get back my energy costs or my initial startup costs for my solar panels. So if I take about what it was, let's say 15.8, okay, and I'm going to minus 6,443, that gives me about 9,300 in kilowatt hours per savings per year. And typically in Massachusetts, the kilowatt hour cost is about 17 cents per kilowatt hour. So I'm saving about $1,600 a year, roughly. I just take that difference and multiply it by the 17 cents. And I know that my solar panels cost about $24,000. So again, I'm just going to do 24,000 as a nice round, divide by 1,600. So it's going to take me about 15 years for me to get back the cost of my solar panels, given this difference. And that's what you're going to end the first week on doing, is playing around, picking a house, throw some solar panels on it, see what happens. And then in lab number 2, you're going to get to design your own house, and you're going to move it to different locations and see whether solar energy is a viable option in different locations. It doesn't matter where. You can also easily try to build and design the location that you're living in, whether it's an apartment complex, whether it's a house, doesn't matter. It's completely up to you. And that is going to be how we're going to use our Energy 3D lab.